Hello, everybody. Good morning. Good morning.
Good morning.
It is a thrill. It's an honor for me to be here with Dr. Siddhartha Mukherjee, who has not only an incredible career as a physician, as a scientist, but of course, as we know, also as a writer, as an author, someone who communicates about science and medicine every bit as brilliantly as he practices science and medicine. And has become truly the historian for so many of us when we try to understand the things that affect all of our lives, from cancer to so much else. So I just told Sid, Dr. Mukherjee, I have a million questions, but we only have 45 minutes. But I do want to start with a kind of basic. You've written about so many things. You have this award-winning book you wrote about cancer, The Emperor of All Maladies. You wrote brilliantly again about the gene, the human, the thing that ties us all together. Then you decided to write about the cell. It's not something we think about every hour of the day, but as you write, it affects everything around us, everything in our lives. Why did you want to do this?
So this project goes back a long way, and it's a little bit like Star Wars, because there are prequels to sequels to prequels to sequels. Obviously, there are two ways to read this book, or read my books. One way is to start with the gene as the fundamental unit of information, then ascend to the cell, and then finally ascend to the dysfunctional cell, which would be cancer. That's one way to read the book. It's not chronological. It's just the way that the books came out. And in the end, when they become a quartet, and we'll talk about the last possible book in the quartet, it'll become what I call the life quartet, an exploration of who we are as humans, how we become humans, what we know about ourselves as humans, at the genetic, at the cellular, and at the pathological level. That's the broad strokes. But let me tell you the particular genesis of this book, which is important. And there are two strands that connect this book. The first strand is that for the longest time in medicine and in science, I would say, general sciences, there was this perception that biology, of all the sciences, because it's youngest, is a kind of lawless science. There are few common principles. I mean, you look at the diversity of life around you. That palm tree and this gentleman who's sitting in front of us, I think, look nothing like each other. Is that a fair assessment? Exactly. So, but they're all two forms of life. Yeah. So the question is, are there deeper strands that are not perceptible? There's probably a lizard outside, there's a bird flying up in the sky. What connects us? What is the thread that connects this vast but extraordinarily diverse-looking thing that we call life? And it turns out there are these things that connect us, and they're incredible. So the first thing that connects us is evolution. The theory, now you could even potentially call it the law, starting with Darwin, evolving into much, much more complex ideas. But evolution runs through this space. Being a literary person, this is just coming to mind. That incredible line from Dylan Thomas's poem, "The force that through the green leaves drives the flower, drives my life." I'm misquoting it, but it's just this incredible idea that there is a force. One force is evolution. It connects us all. There are 1,000 books on evolution. You can read them. Dawkins has written about it. I can quote 1,000. The second is the universality or the universal law of genetics, genes as units of information. There are 1,000 books on genes. I've written one of them, but you can find lots and lots of books about genetics and how we're connected, how that palm tree shares basically the same kind of idea of genetic information than our friend over here, right? And then there's a third law, and that is cell theory. That all of us, birds, beasts, lizards, animals, are made out of cells. And what's amazing about it is when I start writing a book, I start thinking to myself, what's not been written before? And I thought to myself, well, here is the universal principle, just as universal as evolution, just as universal as genetics. And you can't find a book on what cells are. You can find some, but you can't find a book about something that is as fundamental. It's like saying you can't find a book that explains Einstein's theory of special relativity or general relativity. You can't find a book about Newton. It would be akin to saying that for biology. And I thought to myself, that's one reason, so that's one strand. And then, even more surprisingly, we are in the middle of a cellular revolution. And by that I mean we're changing cells, we're doing things with cells. We'll talk about some of this. We're putting bone marrow into humans. In India, I just came back from India. We've treated 15 patients, a company that I started, with T cells and eradicated their cancers. There's a 10-year-old boy whose picture I have in my, probably the proudest moment of my life. There's a 10-year-old boy, and I'll tell you the story in a second. There's a 10-year-old boy who came in with relapsed refractory leukemia. He would have been dead. That is a death sentence. He is now 3 years off his treatment playing cricket. And he came and asked me, can I also play football? And I said, you can play anything because you are cured. You are C-U-R-E-D, cured.
Yeah.
Because of cellular therapy. So, and around the world, if I told people that, they would be saying, what? What are you doing? What's happening? And so these two ideas, the historical importance, and I would say the heuristic importance, and then the current importance, the vitality, the vivacity with which we are taking and manipulating cells, making new things, making new medical products, was completely not there. Just in the same way, when I wrote The Emperor of All Maladies, people didn't know about cancer in the way that book was written. So that's the genesis of this book.
And I want you to talk about why this is happening now. I mean, what led to it? And you have some really phenomenal stories in the book of what scientists over the 5 or 6 centuries have done at moments in time that led to where we are. But I have to ask you about the title, The Song of the Cell. I mean, you're clearly somebody who's as you said yourself, literary. You read a lot. You weave that into almost every page of the book as you write about, something that's complicated science. But why song?
So 2 reasons, but let me talk a little bit about process. There are lots of writers here. And I don't know how people title their books, but I can tell you how I title my books. I have a prospective title when I start a book. And inevitably, it's not going to be the final title. I just put it in there because otherwise I can't move along. My writing process is very unusual. I start from the first word and end at the last word. If someone tells me, move things around and, put something in the middle and just move on, that doesn't work for me. If I get stuck, I get stuck until I can solve the problem where I'm stuck. I can't finish a book. And that's why I need help from editors. Editors can help you get unstuck. But they can't tell you, someone can't tell you, like you can do these days, I know you're going to write about this, leave this chunk alone and move on. And the reason is that books, especially in nonfiction, but also in fiction, books are stitched together like clothes. When you make a jacket, you can't say, I'll come back to the right sleeve later, right? You have to put the whole thing together. And the seams, and this is very important, the seams of a book are where a book really sits. And the more invisible they become, the better the book is, the better the writing is. And so when you move from one topic to another topic, you may be moving centuries. You may be moving from a patient story to someone discovering something under the microscope. There's a seam between those two places. If a reader detects that seam, the book is gone. Because the artifice of writing is to make that seam vanish. And so I'm saying all of this because I usually put a tentative title in, and then I come back to the title. The title came very late in the book, and it refers to two ideas. Number one is that every cell sings out its own song, and by that I mean that every cell in your body, aside from a couple, sperm and egg, every cell in your body has the same genetic information. Your brain cell and your liver cell and the T cell in your body, the B cell, everyone has the same genetic information. And yet, they are completely different in their form and function. They're doing completely different things. And it's very much, it reminded me both of Indian music and of any music in which you hand someone a score, a song, but if you hand Judy a song, she'll sing it differently than if you hand me a song. And in the same way, a B cell and a T cell and a brain cell both have the same score, but they're playing it out differently. They're playing out different songs, and in doing so, becoming different things and allowing themselves to become different things. That's one song. That is what I call the known song of the cell. We now know very much about why and how these two cells, which are very different from each other, can sing out different songs. What we don't know is the second song, which is that that cells are also talking to each other. And there is I would really encourage people to read the last 2 to 3 chapters of the book, where I handle the question of complexity. How do we build complexity out of these individual songs? How is it that when there's a pandemic and a virus infects your body, your entire body has to coordinate a response? It's not one cell, but your entire cellular cosmos has to intersect and create a response. Those are the songs that move between cells, and we are yet to understand all of them. So there's 2 meanings in the book of the word song.
And it does carry throughout the story. You weave in, as we mentioned a minute ago, these really, I mean, you feel you're in the room with some of these scientists going back centuries. What were 1 or 2 of the most important sort of signposts or developments along the way that led us to where we are today when, as you say, we are making these explosive new, the ability to do explosive new things with cells?
Well, I think the history begins with microscopy. And often this is the story of all science. There's an instrument or a tool that comes about, which seems to be unrelated. Microscopy is basically putting 2 lenses together. But the way you put them together and the way you manage to put them together and look down into the universe. So, you know, the story begins with these 2 extremely eccentric, very different characters, Leeuwenhoek in Delft, right. Looking down a microscope, a single lens microscope, which you have to hold up to the sunlight, and finding that in fact sitting inside water were thousands of what he called animalcules, single-celled organisms. And then, on the other hand, Robert Hooke, who was everything. He was a scientist. He was a doctor. He was an architect. He was a scientific illustrator. He was an anatomist. He also built a microscope, looked down, and found that in tissues, plant tissues, he could find these boxes. He called them boxes, and then finally decided that he would call them cella, after the word for a prison cell or a small box, and that's the discovery of cells. So that begins the history of cell biology. That is the moment where all of a sudden we realize that we aren't built out of slabs of meat. But in fact, underneath, if you look at the slabs of meat that we are seemingly built out of, they're actually small units. And we're built in a unitary way, just like a Lego block. And it's incredibly important.
I connect it to, you described as a grad student, looking down, I think you said you had ground up a mouse spleen.
I did.
And you were looking.
As one does.
And what you saw, you said, was very exciting.
What happened?
How so?
So it's so you have an organism, right? Mouse. You have a plant. You have a human. And again, you think of these as they appear to be slabs of meat. But then you take a spleen, you grind it up, and you put it into cell culture, and you separate out all the cellular components of it. You add some factors to make them live, and then you wait for 2 days, and all of a sudden, the things that were in the spleen, the individual cells, you can see them, and they come to life. They're living. And I don't know how to convey the excitement of this. You're culturing life. It's a living being. It has autonomy. It has agency. It has function. It has a capacity to do something, and it's doing something in your body. What used to be on Friday a slab of meat has now on Monday become a unit. And you know that that unit is what's making you live. Now, unless you see it, unless you do it or write about it, it's really hard to convey the excitement of it. It's living. It's a living thing. You've made in a dish a living thing with autonomous agency and function. And now you can study what it does. You can infect it with a virus. You can make it do what cells do. They move around. They search for things. They do things that make us live. And it's incredibly exciting. And if you can't get excited about that, I just don't know what you can get excited about.
You've got to read this book. That pages still jumps out at me, and you do bring it to life, Sid Mukherjee. So fast forward to a lot of time to where we are right now, or in the last few years, where we have figured out ways to take these cells and do really amazing things. I don't even have the language to describe the kind of thing you mentioned a moment ago with the boy, and you dedicate the book to who was then a young girl, and today she's a grown woman.
Yeah, she was 7 when she received therapy with T cells. She is now 18 and applying to college.
Yeah.
She had also relapsed refractory leukemia, and there's no other treatment. So she got T cell therapies and is now, as I said, applying to college.
It's Emily.
Emily Whitehead, yes.
And she.
There's a lovely photograph of her in the book.
Yeah, it's almost miraculous the way you describe what happened, where everything was downhill and then the T cells. But what changed? What was the?
But can I tell you a story which is the craziest of all stories?
Yes.
And I'm sorry to derail this, but sometimes things are so strange that they become stories, and they become stories in books. Okay, here's the story. So I'm just coming back from India. We started against great odds, and we just published a big paper on this, and it's been in the news a lot. We started an Emily Whitehead factory in India. So India has now become the world's 5th largest economy, and a couple of us said to ourselves, why isn't this therapy available in India? We should make it available in India. So we, about 2 years ago, started to make this. So the condition was that I would treat the first patient, and the idea, of course, is to reduce the cost tenfold, if we can. So the cost is forbidding in the United States. We can talk about numbers. It's on the order of $800,000 for this treatment, and we can talk about why. We can talk about how, et cetera, et cetera. Anyway, we wanted to cut it down tenfold, at least maybe even 20-fold. And we've gotten almost there. We're 7, 8-fold now. Every day it's a journey. Every day we cut a little bit more, take off another slice from the pie. Anyway, patient 1, Emily Whitehead of India. I go downstairs and I'm opening the bag. This bag, as I said, is a bag about this big. And in the United States, that bag, it costs more than its weight in gold. So I open the bag. I'm talking to this child, and I say, where are you from? He's then 8 years old. And it turns out he is from Calcutta, which is a city that I visit. My parents are from there. And I said, well, what does your father do? And it turns out, so there is one hotel in Calcutta that I always stay in, which has one floor, which is sort of the floor that I stay in. And there's one guard on that floor. He's the concierge of the floor. And this kid basically tells me through his parents, he says, my father is the guard, is the concierge of that floor. And I'm a little bit shocked by all of this. And so this time when I went back, my flight landed in India at 2 a.m. in the morning. I went to the hotel. I was totally bleary-eyed. I went to my floor, and outside my room, it's hard for me to say this without starting to cry, but outside my room was sitting the guard, the concierge. He had stayed up the entire night, and he was waiting. He said, I saw your name on the roster, because they collect a roster. And he said, you know, my child is alive. Would you come to my house tomorrow? And I said, listen, I can't come to your house tomorrow. I'm doing things. But why don't you bring your child for breakfast? And so I have in my pocket, I'm happy to show you around, but I'm having this pocket me and this child walking up to me from, outside the hotel door. Now, this is a country of 1.3 billion people, of whom 0.1% get leukemia, of whom 0.01% have fathers who happen to be the concierge of a hotel that I stay in, of whom 0.1% have relapsed leukemia, of whom 0.001% have been treated on trial, of whom 0.01% are cured of leukemia. And listen, I don't believe in larger forces, but sometimes, man, I just don't know what to say. Anyway.
And by the way, that's not the only. In fact, that's not in the book. It's
not in the book. It just happened.
In the book.
It happened last month.
But your encounters with other patients are woven through this book.
Absolutely.
And I have to say, when you read it, you go back and read it again and again.
Yeah.
Because these are just incredibly moving moments.
I'm just looking for the picture. It's anonymized. So anyway, Judy, you can see it. The audience won't see it. This is the kid.
Oh my gosh! You all have to come up and look at this. You're gonna have a mob up here. Oh my gosh! He looks wonderful. He looks wonderful. Can I hold it up?
Yeah, hold it up.
There's a little bit of
he's
a shadow.
Anonymized, so.
Yeah, there's a shadow over his eyes. I don't know if you can see.
And alive 2 years after from a disease that is absolutely deadly was a death sentence 5 years ago. Anyway, I thought I'd share that. No one's ever heard it. I just came back, so.
But the book has a number of
Of stories like that, yeah.
stories like that with patients. But talk again. What was it that was the key or keys that made it possible to do this kind of miraculous stuff today, using the cells, whether T cells or other pieces of cells, to do this incredible work today?
You know, there's a kind of shoulder of giants phenomenon here, which is incredible, because you don't wake up one morning and figure out that there's a T cell in the body that fights infections. You do it very step by step. So there is a lineage in which you understand how the body is made, and then you ask the question, a very simple question, which was asked in the 1950s and 60s. The question was, how do we defend ourselves against invaders? We're constantly under attack from various viruses, invaders, et cetera, et cetera. We've run through a global pandemic. What cures, what heals us? What is the mechanism? What is the immune mechanism that heals us ultimately? When you get influenza, influenza is a virus. Its job is to replicate inside cells and make more copies of itself. So why don't we completely succumb once we are infected by influenza and become an influenza factory for the rest of walking influenza zombies? Why not? Right? And I love questions like that because they get to the bottom of things, because you ask the counterfactual. The counterfactual in the 1950s was, why isn't everyone in this room an influenza or bacterial zombie, walking around making more copies of that bacterium or influenza that's infected you? Why aren't we all COVID zombies? How do we recover? And that question, asked in the 1950s, led to the discoveries of there must be something, there must be in the body a system that allows us to fight invaders. What is that system? It's a cellular system. What cells are in it? B cells, T cells, other cells, a whole bunch of them. How do they coordinate with each other? What signals do they send each other? What happens when you get an infection? And slowly, bit by bit, like solving a jigsaw puzzle, you suddenly realize that there are these cells, T cells. And then you begin to realize that these cells, in fact, can be manipulated, not just to fight infections, but you can engineer them so they intersect with genetic engineering. You can engineer them potentially to fight cancer. And that's the basis of this new kinds of cellular therapy. But that's not just one, that's just one example. You know, we are building skin. We are building from cells. I'll give you other examples, things you don't really think about. Blood transfusion. One of the most common things that people do. Safe childbirth would be impossible without blood transfusion. Because once in a while, you have a gush of blood and you can't stop it, and it's lethal. Women would die of bleeding from childbirth. Blood transfusion can only happen because we identified what cells were important, red blood cells, and identified compatibility, which ones were compatible with each other. Because if I give you the wrong blood, it won't, you'll have a reaction, it won't stay. So IVF is cell therapy. So things that we really think have become, we sort of absorbed them and said, blah, blah, blah. But they're in fact the consequence of slowly understanding that we are built out of cells, that we can manipulate cells, we can transplant cells, we can move them around, we can change them. And so all of these new therapies, some of which we take for granted, are really the consequence of understanding the basic biology of cells.
So it's cancer, it's also, you write about diabetes, the pancreas, sickle cell, anemia, just extraordinary work that's being done there. There's so many possibilities. What are you, at this point, what are you the most optimistic about in terms of advances in the near term? And by the near term, years.
I think the intersection of cell biology and genetics. In fact, if you took my last two books and you smashed them together, the intersection of cell biology and genetics is creating an incredible revolution in medicine, which we have to be good stewards of. So again, in the last chapters of the book, I talk about, on one hand, very optimistically, about our capacity to manipulate cells. Incredible. But also it comes with lots of problems. Some of the problems are philosophical. Once we start doing this, manipulating cells, increasing, changing cells, we really are changing humans.
Yeah.
And that's why the subtitle of the book contains the word new human. It's a provocative word, because the question is, who do we become? And then there are some questions that are philosophical that have to do with equality and equity. I mean, if they're going to be, if they're going to cost $800,000, most of us won't have access to them. And so who has access to them? And so there's a series of questions at the end of the book which have to do with, on one hand, have to do with autonomy and identity, and the other hand have to do with, the economics and the accessibility of these therapies. So on one hand, I'm incredibly optimistic about the coalescence of genetics, gene therapy, and cellular biology. But on the other hand, I have pretty serious worries about what might happen once this is let loose.
And how do you've been all over the world. You've obviously spent a lot of time in India. You're working there, working here, and other places. How do you see that? I mean, to me, that's just one of the big questions coming out of the book, is whatever advances are made, how are decisions made? Who makes decisions about who gets the benefit of these treatments and who doesn't?
Well, right now, those decisions are so constrained by economics, about resources and things like that. They're extraordinarily constrained. The real question is how to make them less constrained. Sometimes I tell people, we're not making gold here. We're making cells. We're genetically manipulating cells. There are some costs, labor costs associated with it, quality costs associated with it, but we're not spinning gold. So at some point of time, this journey will end, I think, with vastly more accessible variants of these therapies. And to use a very simple example, 100 years ago, did you think everyone would have cell phones? No. Technologies have scale. They scale downwards, hopefully. And we, obviously need to create an ecosystem of resources in which these resources are available to people. That's the resource problem. That doesn't solve the philosophical problem of who we become once we start doing cellular manipulations on ourselves. That's a question about stewardship. That's a question about who we are as humans, how we define ourselves as human, what the new human is.
I want you and we spoke beforehand about, I wanted you to read a little bit of the book where you refer to Paul Greengard, who was someone who was a mentor.
Yeah, and a close friend.
To you and a close friend. He was in his 90s
yes.
when you reached out to him, but I don't know if this is the exact page, Sid, but
yeah, I'll find it, yeah.
There's a part of it, but it's integral to telling the story in the book.
Yeah. The way, just a little bit of background to this, the way that I write books is I think of myself as a kind of recipient or a filter, in which, by filter I mean not a filter that removes things, but when you put a dab of ink on a filter, it just spreads. And so if things happen to me as a physician, as a scientist, COVID and my confinement and my time during that period, my father's death, my own my depression, my mental anguish, I feel as if I don't tell you about that, I would be a lesser writer, and I would be sort of this kind of physician who doesn't seem to experience anything in their own lives. So this piece it was published in The Guardian. This piece is a very personal piece, but I decided to put it, I wrote it because it just felt natural. Because if you're going to write a book about medicine, and if you experience something that is medical, it should be in the book. So I'm going to read it, and you'll figure out why. In the spring of 2017, I was overwhelmed by the most profound wave of depression I've ever experienced. I use the word wave deliberately. When it finally burst on me, having crept up slowly for months, I felt as if I was drowning in a tide of sadness that I could not swim past or through. Superficially, my life seemed perfectly in control, but inside I felt drenched in grief. There were days when getting out of the bed or retrieving a newspaper outside the door seemed unfathomably difficult. Why? I could not tell. Part of it perhaps was coming to terms with my father's death a year before. In the wake of his passing, I had thrown myself manically back to work, neglecting to give myself time and space to grieve. Some of it was confronting the inevitability of aging. I was at the edge of the last year of my 40s, staring into what seemed like an abyss. My knees hurt and creaked when I ran. An abdominal hernia appeared out of nowhere. The poems that I could recite from memory, I would now have to search my brains for words that had gone missing. I heard a fly buzz when I died. The stillness in my room was like what? I was becoming fragmented. I was officially entering middle-aged, and it wasn't my skin that was beginning to sag, but my brain. I heard a fly buzz. I called Paul Greengard, a professor at Rockefeller University. I'd met Greengard at a retreat in Maine several years ago, and we had recognized each other as fellow scientists and walked for a mile on a white-pebbled, windswept beach, talking about cells and biochemistry, and had become close friends. I'm skipping ahead a little bit. In the 1960s and 1970s, Greengard's experiments had led him to think of a novel way about cellular communication. Neurobiologists who studying the synapse had largely described the communication between cells, neuronal cells, as a rapid process. But Greengard had argued that there was a different kind of process by which cells talk to each other. The chemical signals sent out by one neuron to another create a cascade of what he called slow signals in the brain. Neuronal signaling from one cell to the next, he argued, instigates profound biochemical and metabolic changes in the recipient cell. An elaborate cascade of chemical signals is passed off, which cause alterations in metabolism and gene expression, in the nature and concentration of chemical transmitters, and ultimately in the way the cells communicate with each other. For decades, the slow cascade was considered peripheral, but the biochemical alterations produced by neuronal cells, the Greengard cascade, is now known to permeate the brain, change the function of neurons, and dictate many of its subsequent properties. And for this, Greengard would win the Nobel Prize. The important thing about that is that Greengard thinks, and now we think more and more, that this slow transmission is the cause of many, many neuropsychiatric illnesses, perhaps most interestingly of depression. And that's probably why, this is Greengard's hypothesis, that just increasing serotonin in the brain using the standard antidepressants, SSRIs, doesn't work. It's because it's this slow process that takes months in which the way the neurons communicate with each other that has to be modified. And it can be only modified maybe through serotonin, but probably through chemicals that we don't even know yet. And once we know those chemicals, we can alter the cells and their communication between them, the slow communications between them, change the synapses, and create a new brain, and this goes back to the new human, create a new brain where the circuits responsible for depression are finally alleviated. It's a completely new, different way of thinking about mental and mental pathologies, including schizophrenia, Alzheimer's disease, and other diseases. But it's a new way of thinking about things.
It's just one example of the many, I overuse the word dramatic, but dramatic elements that you sprinkle through the book that make it, yes, it's a book about science, you learn so much from it, but we learn about you and who you are and your life, and we learn about these remarkable people who are in your life. I see we only have less than 4 minutes left, but would anyone like to ask a question? The gentleman who's not the palm tree
Yes.
on the first row.
First, Judy, for all of us that had you in our homes for years,
Thank you.
made such a difference in all of us.
Thank you. Thank you very much.
Doctor, in 10 years when you're invited back to give a talk, what might you tell us happened in these 10 years to advance our lives in healthcare and well-being?
Well, I think I would love to say that we've cured type 1 diabetes using cell therapy, that we've implanted artificial pancreases into people. I'd love to say that we have 5 or 6 new cellular therapies for cancer, particularly liquid cancers that have been successful. I'd love to say that we have advanced IVF so that we are not implanting 5 or 6 embryos into humans, but rather one, and being sure that that one embryo, if people want, some people might want 2, 3, but if people want one, that we've been successful in implanting the single one that we know is going to lead to a healthy, viable child. And finally, of course, going back to the questions we asked a little bit before, I'd love to say we've cured sickle cell anemia. I'd love to say we've cured beta thalassemia. But finally, I'd love to say that we've made the resources available so that people who are really in need of these therapies can access these therapies without becoming, without breaking their banks and without breaking the national bank of monies that are available.
I know so many people in the room agree. I lost my sister this last year she had type 1 diabetes complications. We've got about a minute, so if it's a short question right here.
Well, so when we first started,
This is about Emily.
this is Emily Whitehead's. So the question is, did Emily Whitehead are there no side effects, or are there side effects? This is how medicine evolves. Emily almost died from the side effects. It's in the book. Because when T cells kill cancer, they go on a kind of rampage. That rampage is very toxic. In the last 5 years, we've learned to manage those side effects so much so that they've almost become nil. They've gone from being deadly to becoming nil, partly because, again, life is strange. So Emily Whitehead's case is interesting. I'll just tell you a quick story about her, and then we have maybe one question. But it turned out that Carl June, who's a friend, who was treating Emily Whitehead, happened to have a daughter who happened to have juvenile arthritis, who happened to be treated with a drug, which was an immune suppressant drug for juvenile arthritis. Emily Whitehead was about to die. Her cancer was killed, but she was about to die from these rampaging T cells. And Carl June, in his great wisdom, decided that why not try this immune suppressant drug to dampen down the T cells? Now that they've been awoken, now that the monster is awake, why don't we put the monster to sleep again? And so overnight, they rushed a requisition and treated this Emily Whitehead with the drug and completely changed. So all of the T cells went back into their quiet
Yeah.
mode, and that's why she's living. That trial was almost dead. So now what we do is we give that drug as a prophylactic, and we also give the doses of the T cells in fractions, so we don't give them all at once swell. And I would say the side effect profile has gone down to basically nothing. Virtually everyone's fine. We have maybe one last question, Judy?
This gentleman.
Yeah, I worry. I mean, so the question is, do I worry about the overly reductionistic approach to medicine? And this book, I mean, the last chapter is exactly about that.
Yeah.
I think I think you have to be careful about words here and definitions. So it's easy to define the reductionist piece of it. It's very hard to just define the holistic piece of it. By holistic, I mean taking into account the whole, which involves taking into account the intercellular communications, the environment, diets, nutrition, how our brains intersect, stress, inflammation, things like that, which we know very little about. That is what I mean by taking the whole into account. Other people might have different definitions. My general plea has been, if you're going to talk about medicine holistically, let's be clear about what the definitions are, because I don't want slippery definitions. I want something that I understand, I can test, where I can provide proof to a patient that is proof that allows the patient to become well again. Because the problem is, when you're a patient, and I know this from my own experience, everyone gives you advice. There's no limitation. You're on a bus and someone's giving you advice about what to do, and all you can say is thank you. But everyone's a doctor. Everyone's giving you advice. And so my general plea is, and most of this advice is about what you might call sort of holism and holistic medicine. Everyone's saying, oh, reduce the stress in your life. And a cancer patient is saying, what do you mean reduce the stress in my life? I have cancer. You go reduce the stress in your life. And so I think there is a side of holistic medicine or holism, which, when we become slippery about it, actually ends up blaming the victim and actually ends up harming people. And it's really important not to do that, because you can tell everyone you can tell cancer patients to eat goji berries and stand on their heads. Someone in the bus is going to tell you that and say that that's the way to cure cancer. And what you've really done is taken that person whose life is already pretty full, their bucket is full, and you've added 2 more drops of water to their bucket and say, now, beyond going to your doctor and getting therapy and getting psychiatric counseling, which I think all of which are important, you also have to eat goji berries and stand on your head every day, right? And I'm like, the patient has cancer. Give her a break. Thanks for your holistic medicine. But if it's helpful, let's make sure that it works, make sure it's tenable, make sure there's some proof behind it, make sure there's scientific evidence behind it. And sure, if there is, I'm all for it. But don't fill this woman's bucket. It's full already.
Great question. Dr. Sid Mukherjee, thank you.
Thank you.